Does this count as woodworking? I mean, it is wood and I'm working it. I hope not though, because I've thrown a lot of shade at woodworkers over the years. And I am never going to live this down because the internet never lets you live anything down. Hello Internet, my name is Quinn and this is Blondihacks. It's time for the finishing touches on my vertical fire tube boiler. We've got lagging to do and some other little details that are needed before this thing can really be called done. So let's go. Here's the story so far. I've got the boiler basically done and operational, but it's still bare copper. And so I've got a pile of mahogany strips here to put on top of it. This is called lagging a boiler, and the purpose of it is to provide insulation. Steam power is external combustion, unlike the modern internal combustion that we're all used to. In internal combustion engines, heat is the enemy. In external combustion, like steam, heat is precious, and you got to do everything you can to keep it inside the systems. So insulating the boiler helps considerably. I took some measurements and made one master strip of mahogany, and that'll be used to make all the other ones since they're all roughly the same length, and then some elastic bands on there to hold them in place while I cut and measure. And it's important to keep things square as you go, much like with tile or flooring. Otherwise, when you get around to the back, you're going to be all cattywampus and, well, then you can't show your face at the Model Engineers Club anymore. I find side cutters are the easiest way to cut this stuff. I've tried saws and knives and various things, but even at this small size, mahogany is tough stuff, and it's actually not that easy to cut, so side cutters do the job. It leaves a bit of a pinch end though, so if the end is going to be exposed, then I like to also file it square again. Once again, keeping things square as I go. Now, I like to start with the hardest part of the boiler, so I'm doing this middle section here, and now I got to start scribing around the boiler bushings. So I've got a piece set into place here with the right amount of stick up there, where it'll go under the smoke box lid there, and I'm just eyeballing the outline that's going to be required, and I'm just erring on the small side, so I know that this initial pencil line will be too small. And for this, I used two different methods to cut these out. I did use an X-Acto knife. This works. You have to do a lot of light passes and it's quite a lot of work, and then the resulting cut has to be squared up with a small file. The other method that I think works actually better is just to use a large, coarse, round file and just file the shape directly in there. And you can change the direction of pressure to move the hole around as you go. This process is just as tedious as you expect. It's a lot of test fitting and checking and filing and test fitting and checking and filing and so on. But eventually you get to a point where that piece will slide in, and then you can reinstall the piece next to it that was removed for clearance for test fitting. And there we have it. You really want to plan your pieces a little bit here because you don't want to be left with any pieces that won't be supported by boiler bands, and you want to try to avoid any pieces that have cutouts in them that are too thin. So I basically went for a symmetrical split on the boiler bushings there as much as I could. I am going to end up with two little pieces between the boiler bushings, which you can see is sitting loose there. That will require a special boiler band basically just for those little pieces. It goes quickly once you're past the bushings, and then you get around the back, and unless you're a lot luckier than me, you're going to end up with one strip left over that's narrower than the strip would. So for this, I just mark the width that I need, and I'm going to cut this piece down. So this is the ripsaw of the model engineering world, just a sharp knife and a steel straight edge, and a lot of very light cuts to keep anything from moving while you do this and to get a good, clean, straight cut. I should say this strip wood is 1/16 mahogany craft wood, and I just buy it on eBay. But if you have woodworking tools and more skill than me, you could also just cut these strips yourself. Some people also like to put silicone rubber or ceramic paper, things like that, underneath the wood for extra insulation, and that's fine if you want to do that. I chose to just go straight with the wood. Okay, time for boiler bands, which are the permanent version of the rubber bands there. You can see those two little pieces between the pairs of bushings. They need a boiler band, and then there will be one around the bottom to hold the bottom edges of the strips there around the firebox. So I start with this brass banding material, which you can buy online. It's sold on eBay as boiler banding, but you can also buy it on McMaster-Carr or places like that once you get your search terms figured out. I start by marking it roughly for length and then cutting that down, but before final fit up, I like to anneal it because cold working this stuff is quite difficult. It's pretty stiff and it doesn't want to bend around the cylinder there, and it's hard to get the length exactly right, so annealing it makes it really butter soft, and you can just wrap it around the boiler like a strip of paper. So make sure every section of it has seen some cherry red and let it cool down, and now it wraps around there just like butter. I really love working with annealed brass in a situation like this. So now I can wrap it around there, get it lined up in the place that I want, and then mark it for length for the final time and cut that down. Next, we need the little clamping blocks that hold the bands in place, and for that I needed some 1/4-inch brass square bar. I didn't have any. I've got this larger stuff, which I think is 1/2 inch or 3/8, not sure, but I'm going to cut the stock that I need out of this, and so I'm going to start by squaring off the end. I'll mark the length that I need here. I don't want to convert this entire piece. I just need a little bit here of smaller square stock. I'm going to clean up the top surface here to give me a good reference surface, and then I'm going to do something a little crazy. I thought I'd see if I could get away with this. I'm going to try to get the rest of the stock down to dimension in a single setup. And to do that, I'm going to flip it over, since I don't need that side anymore. We're done with that side, and I'm going to stick it out past the edge of the vise, and now I can machine all 3 sides from this single setup. Now this setup is not very rigid, so it remains to be seen if I can get away with this, but I'll start by machining this top side down. This is opposite the side that we cleaned up, so this is going to be final dimensioning that I'm doing on this side. So I just machine this down, checking the length until I have the thickness that I want. Then I bring the cutter down and I side mill the back surface. Again, a light cut just to clean it up. I can use an inspection mirror there to make sure I'm fully cleaned up. That looks good. And now I can come around and attack the front surface. Now the strategy here is that I'm not trying to cut the middle out of this chunk of bar stock. I'm just trying to get a square chunk that's smaller. So that's why you can just clean up one surface and then mill the other side down. I'm effectively taking just the lower corner of this stock. If for some weird reason it had to be the middle, then you'd have to do a lot more work here to find the center lines and things, but that's not what we need. But now as the stock gets thinner and thinner, I'm starting to run out of rigidity, which I feared I might. You can see chatter marks starting to appear on the surface, things are vibrating. So I got as far as I could with this, but my luck ran out, and so I had to go ahead and cut it off, and I'll have to change my setup to finish this. It was a neat idea and would have saved me a lot of time if it had worked. If the piece was a little shorter, I might have got away with that. But I got 2 of the cuts that way, and now I just have to finish it up with one last setup. Again, stuck it on the end of the vise so that I can get the micrometer on there to check the dimension, and then it also allows me to clean up the end once we are at dimension. So there you go. That was a lot of work, but it was less time than waiting for new stock to be shipped to me that was the dimension I needed. Now I've got my Artisan small batch square bar here, and I'm going to set it up vertically using the 2 parallels trick. This is surprisingly accurate for how fast it is. And then I'll use the edge finder to find the top center here. What I'm doing here is I'm drilling all the way down through this entire piece of stock because I'm making 2 band clamps, and each band clamp is 2 pieces. And all 4 of those pieces need a threaded hole on one side and a clearance hole on the other. So a base operation of the tap drill size all the way down through the whole piece will effectively give me 4 operations for free. Note my very depth conservative peck drilling here. This is both because it's a very high aspect ratio hole and because I really need this hole to be well centered all the way down. Otherwise, one of the 4 pieces will have the hole in a weird place. It's very easy for a hole like this to get crooked. And now I can take it over and cut the pairs of band clamps apart. I start the cut with the fret saw because it's more accurate, and then I get a nice little groove going, and then I can finish it with the hacksaw, which is a lot quicker. And then I just cleaned up those hacksaw cuts with a file. No sense setting up the mill just for these tiny little cleanups. And then I take each block, which is again a pair of clamp pieces, and I tap them all the way through. And this will make sense here later. Then I center punch the bottoms, and the punches are to provide clearance for silver solder. So I got some flux on there, and I clamp each piece across the split line on the boiler band. And I'm clamping it, but the punch marks are going to keep a very tiny amount of clearance underneath the block for the silver solder. So I got my torch on kind of low here because these are small parts and I don't want to heat them up too fast or too much. And I just heat that up and touch the solder in there. And then wash some heat around, make sure the solder is well flowed all the way underneath that block there, between the block and the boiler band. So that looks like a good joint. The block is a little bit crooked on the band, but that's okay because we can clean that up at the end with a little bit of filing. I made both bands that way, and then into the pickle bath they go. That's Sparex number 2 pickling acid. It's good stuff. It's just about as fast as sulfuric acid, but a whole lot safer. And after 5 minutes in there, they are cleaned up and into the rinse, and then all the crud and everything just wipes right off. Now we're ready to separate them. So for this, I've got the fret saw out. I want to make a very fine cut right down the center with minimal kerf here. I don't want to lose too much of the material of the blocks there. Once those are separated, now we're ready to make them into clamps. Remember, I threaded them all the way through, so now I just take one side and open it up to clearance size for the fasteners that are going to go in there. And now they are clamps. So they got a little bit of a cleanup on the Scotch-Brite wheel, and I also clear coated them so they'll hopefully stay shiny and yellow. Back to the woodworking, I'm going to finish the mahogany with tung oil. This is what I used on my last boiler, and it worked really well. So I put the tung oil in there, and then I dilute it 50-50 with paint thinner. This is what they say to do on the package of the tung oil. Also good to thin it because tung oil is expensive. The next step is to frantically search for a container for which paint thinner is not a solvent. Then resume mixing, and later you can clean up the mess left by the melted plastic cup that you used the first time. I don't know why that's part of the steps, but it is. You can do a little test piece here just to make sure you've got the mix about right. The thinner you make the tung oil, the lighter the color will be, but if you get it too thin, it won't be an effective waterproofing, which is the whole point here of treating the wood. So I removed the little loose sections there so they don't fall out, and I proceed to coat everything in the tung oil mix. The last time I did wood lagging, I did a lot of research on what to do for this treatment. A lot of people use polyurethane or various other things. It does have to take quite a bit of heat, so you got to think about that when you're choosing your wood treatment. But the tung oil on my last boiler worked out super, super well. It's just stayed really, really beautiful, and it seems to take the heat no problem, and it seems to do a nice job of waterproofing the wood. So I do recommend this tung oil as an approach. But I think polyurethane is more traditional, so, don't listen to me. The last little section here, almost done, completely coating the wood on the boiler, looking really nice. One little spot left there. All right, well, that last spot is for my patrons, so go ahead and check out the video over on my Patreon if you want to see me finish that spot. Oh, not gonna do it. Not gonna do it. I'm just kidding, I'm not a monster. There you go. Well, I am a monster, but not in this specific way. And I can remove the masking there. I opted to do this with all the fittings in place because everything is watertight right now and I don't want to disturb everything, so I just worked around them. Next, the little loose pieces go in and I can finagle the top boiler band in there. This boiler band exists entirely to hold those two little pieces in between the boiler bushings there, because as the top of the strips are held by the smoke box lid and the bottom has a boiler band. So if you do this right, the boiler bands will close up tightly just like that, and everything will be snug and no gap there. So that looks really nice. Now, if you don't quite make it, you can also just file a little bit of material off the insides of the blocks there until they close up snugly. They don't have to be crazy tight because the boiler shell is going to expand when it heats up too, so you don't necessarily need to cinch it down like a hose clamp. It's just to keep the birds from stealing the wood. I've got one open bushing there that will be for a water feed pump, but I'm not ready to do that yet, so I just shined up one of my mangy old blanking plugs and I'll stick that in there for now. The last detail I want is a base for the boiler. This boiler is destined for a steam plant on a wooden base, so I figured some metal down there would be a good idea to protect the wood a little bit from the heat. So I got a piece of brass here pre-cut on eBay, and I found the center of it there and set my dividers to the radius of the inside of the firebox, and I'm marking that on there. And then I'm marking 3 positions 120 degrees apart because that's what I have on the firebox for mounting holes. Way back when I was doing the machining on the boiler shell, I left 3 mounting holes there. Now is their time to shine. So just double checking with the dividers that my spacing is correct. These little blocks were whipped up on the mill, just basic machining, drilling, and tapping, and there's punch marks on the bottom again for silver solder. So the idea is the burner will sit in the middle of these 3 blocks and hold the shell in place and the burner in place. Now they're a little too thick, so I measured the excess thickness there and then whipped that off on the mill. This being brass, I can do it in one big beefy pass. Brass is fun on small machines because you get to pretend that they're big machines. A little test fit here, and that looks like that is going to work. So the idea is these little blocks get silver soldered to the base, the boiler is bolted to the blocks, and then the insides of the blocks hold the burner. I'm going to need some bolts for those blocks, so normally I would start with hex bar stock because it's convenient, but all I have is some round bar in the correct size. But the Engineer's Black Book has these great formulas in it for how to turn round stock into hex bar stock. You can easily calculate the distance across the points of the hex from the flats that you want, and then turn the round stock down to that size. And then we'll put the hex on it here in a minute. But I'm going to start by turning down the threaded area for some threads. Then I'll put a nice friendly rounded end on there. Then I take it over to the mill and set it up in the collet block while I still have it on the waste stock, and using the hex collet block I can easily put the hex sides on there. And now it's officially a bolt and we can part it off. Yahtzee! There's the 3 bolts, deburred and shined up and ready to go. I decided to paint these the same black as the firebox so they'll kind of blend in. And now I'm ready to solder these little standoffs in place. I'm carefully lining them up using the marks that I made for the normals of the threaded holes and then using the chord of the circle across the blocks to get them straight. This is very important because otherwise the holes won't line up. I found this scrap of steel from some previous project to act as kind of a welding finger there, put some weight on the block, and that will hold it in place during silver soldering. Again, the blocks are punched underneath so that they'll have clearance for silver solder even with the weight on there. Little piece of solder on the back and heat it up. Now the plate warped quite a bit more than I expected. I did not anticipate that, but we'll have to deal with that in a minute. But I proceeded until the silver solder flowed, and that looks like a really good joint. So all 3 were done that way, and then into the pickle bath once again, and then once again a rinse, and I cleaned it up a little bit on the Scotch-Brite wheel. I didn't go too crazy with trying to polish this thing because I don't know what the final steam plant is going to look like or how visible this plate is going to be in the end, but I did at least even up the Scotch-Brite wheel marks a little bit with some 2000 grit paper, and I'll do more with this later, but for now I just need to have a mounting plate option of some sort for this boiler. Final test fit here, burner goes in the center, boiler goes down on top, and I was due for a little luck on this project, and all 3 holes lined up. So considering how those blocks were placed clumsily, I'm kind of shocked that that worked as well as it did. Well, we didn't get it all dressed up for nothing. Let's run an engine on this one more time here, because, we gotta, right? So I'll pull the safety valve off, screw on my custom threaded 3D printed funnel, fill this up, and let's get a fire in the hole and make some steam. Here we go, 50 pounds on the clock, run the water through, get it past the rings. Well, there it is. That is a vertical fire tube boiler built from scratch in 16 parts. I thoroughly enjoyed making this boiler, and I learned a ton from it. It was definitely a character building experience. Let's let the engine do the talking here for a minute. There are more little things that I will be doing to this boiler over the years. I need to upgrade the burner a little bit, Got to build a feed pump for it, and someday there is going to be a steam plant project on this channel, but you know, art is never really finished, it's only abandoned. So for now, I am calling this boiler done. It's pretty crazy to think that I started with a spreadsheet, and here we are a long time later, months, weeks, I don't know, how long has it been? It's been a long time, and here we are with a functioning boiler in the world that did not exist when I started. And you know, that's why we do this, is to create things in the world that wouldn't be there if not for our little footprint on this planet. Thanks for joining me on this ride. I hope you enjoyed watching the process, and I hope you'll try making stuff like this too, because you can do it. If I can do this stuff, you can do this stuff. Thanks for watching. Thanks especially to my patrons. All my viewers are the finest of humans, but my patrons are a little bit finer. Wait, the definition of finest means nothing can be finer. Look, let's not split hairs here. Thank you all, and I'll see you next time.